measure the flow rate. Okay, so how to measure the flow rate using vias? First we need to calculate the coefficient of discharge for this particular via. Okay, whether it's a rectangular via or triangular. Okay, so there are so many types. Okay, so you can see in the manual it has so many types of vias, whether it's rectangular or triangular. Okay, first we need to determine the coefficient of discharge. Once if we know the coefficient of discharge, there is a equation. Using that equation, we can directly determine the flow rate. Okay, so when you know the height, we can directly determine the flow rate. Okay, so the height can be easily measured. Okay, so normally now we have like ultrasonic sensor. If you fix the ultrasonic sensor, it will measure the height very accurately. Okay, once you know the height, you can easily calculate the flow rate. Okay, so this is normally used to calculate the flow rate in long water channels. Okay, where sometimes you cannot go and measure it properly. Okay, even sometimes during the rainfall. Okay, it's not in Saudi Arabia, other places like in Malaysia and all. So there will be a lot of water channels will be there. Okay, during rainfall, suddenly the water level will increase. Yes. Okay, so how to calculate the flow rate? Mostly they will use the VS to calculate the flow rate. Okay, so by measuring the height, because it's difficult to measure the flow rate, but by the measuring the height will be very easy. We can fix the ultrasonic sensor somewhere. Okay, so you can easily measure the height at any time. Okay, so once you know the height, then you can measure the flow rate accordingly. Okay, so how to do this experiment? First, what you have to do is, okay, so there are two types of vias we are going to use. Okay, so this is rectangular. Okay, so another one is triangular via. Okay, so what you have to do is, first you need to make this level as 0. Okay, so here the water is full, okay, but it's not going out. Okay, it's not overflow. Okay, so this level first you need to measure and make it 0. Okay, so you can adjust this. Batch. Okay, now you see it's inside. Okay, so just adjust this. You can see bubble kind of thing.
The tip is
Tip is inside now. Okay.
outside. No, that's outside. Yes. Yes.
It just touch.
Okay,
now
that's
it's just touching. Okay, so this you make it as 0. Okay, this is the datum level. Okay, so this is 0 level. So here you need to adjust this. Okay, you must adjust this to 0 here. Okay, so now we already made the level to 0. Okay, so now if you increase the flow rate, okay, there is a wall, slightly open the wall. That is gate valve here.
Gate valve.
Yes, yes.
Slightly open.
Keep right with or like this.
It's already closed, so make sure you start from the minimum. If you increase, then it will overflow. Reduce the flow rate.
بعدين
it's steady. Okay, now you can see. Okay, when you adjust this, you can measure the height because you already made it this one to 0.
Also, that was the first reading at 0, huh?
Yeah.
So now we'll take the reading of this flow.
Yes.
Also make the tip on the surface water. Oh. Okay, that's it.
Okay, just touch it. Okay, so now you check the reading here. Okay. So 2 and 3. Okay. See the line? It's between 2 and 3.
Yes,
So
yes.
1, 2, 2 and 3. Okay. So that means the main reading is 2 mm. Okay. So to measure very accurately whether it's 2.1 or 2.2, you see these 10 lines. Okay. If you look at these lines, only one line will match exactly. Other lines you can see it won't match.
Oh, it's like the vengeance.
And there will be slight difference. But if you see these 10 lines, only one line will match exactly with any one of the lines.
Yes,
So
yes.
you see which line is matching. Okay, so 1, 2, 3 is not matching, 4,
8,
like
I think 8.
5, not 8. Is it 8? You see 4 or 5. Make sure the flow is steady. After that you measure the height.
Okay.
Clear? So the first point is you need to make it 0. Okay.
The first point.
Means just when it started overflowing. Okay, means when it is full, you measure. Okay, so the 0 is this height. Okay, so this height is 0. So after that, the second you need to slightly open the valve. Okay, then allow the flow to be steady. Okay, because it will take some time to be steady. Okay, so after that you measure the height. Okay, so while you are measuring the height, what you have to do? Okay, so you need to close this one. Okay, if you open this, it will drain. Okay, so you have to close this while. Okay, so you need to. Yeah, this is the actual flow rate. So that's the theoretical flow rate. Can you open? Okay, now you see the water level will increase. Okay, so when it comes to 0,
Stop.
okay, 0 means the bottom should be 0. Okay, so that is, you see here, there is a bubble like thing. Okay, so the bottom of the bubble should coincide with 0. Okay, not the top, bottom. Okay, bottom should coincide with 0. When it reaches 0, you start the stopwatch. Okay, when it reaches 0, you start the stopwatch. Okay, until you wait until 10. So when it reaches 10 liters, so this is liters. Okay, when it reaches 10 liters, you stop the stopwatch. So you know the time for 10 liters.
10
Okay, for 10 liters, how many seconds?
How many seconds?
So that's the actual flow rate. Okay, because you are collecting water, that's the actual flow rate. Okay, we are measuring the height. From the height, we are calculating the flow rate. Okay, so here is the formula. Okay, so how many seconds? Okay, theoretical flow rate you are calculating using this formula. Okay, here B is the width of the rectangular notch. Okay,
Which is known.
sorry.
Should be known.
Yeah. B is 30 mm. It's given here. Okay, so the width of the rectangular notch is 30 mm. Okay, so B is 30 mm here. Height is the one which you are measuring. Okay, so make everything to meter.
So we should make 5
readings. Five readings.
5 readings.
Okay, so five trial runs you have to do. Okay, in 5 trial runs. Okay, so the theoretical flow rate you have to calculate. Also, you need to calculate the actual flow rate. Okay, how to calculate the theoretical flow rate using the height? Okay, use this formula. Okay, so the reading which you have to take is height versus volume is 10 liters. Okay, you can fix it the time. Okay, so from that you can calculate what is the actual flow rate and what is the theoretical flow rate. So you can compare. Okay, actual flow rate and theoretical flow rate. But the objective is to determine the coefficient of discharge. Okay, so how to determine the coefficient of discharge? Okay, you need to plot actual flow rate versus height. Okay, Q actual versus height. Okay, means log. Okay, 1, 2, 3. What you have to measure is the height. So this will be in time. Time in seconds for 10 liters. Okay, for 10 liters, what will be the time? So you need to note the time for all the 5 runs. Okay, so once you know H, you can calculate. So you need to plot. Okay, you have to after that. Okay, so from the time you can calculate what is the Q actual. Okay, Q actual you need to calculate in meter cube per second. Okay, this is in liter per second. Okay, this is 10 liters second. Okay, you need to convert into meter cube per second. Then height will be in mm, you need to convert into meter. Okay, so you have to calculate log Q actual. Okay, you have to take log value, then log H. Okay, so you draw the graph between log Q actual versus log H. Okay, so you will get a straight line, so you will get 5 points. Okay, so maybe the points may be here. So join the points. Okay, so make it as a straight line. That's very important. So it will be a straight line.
What's the points?
Yeah, you should have minimum 3 points. Okay, to connect the straight line, you should have minimum 3 points. Otherwise, you can connect anything. Okay, if it is only 2 points, you can connect anything, but you should have minimum 3 points. Okay, then from the intercept, you can calculate the coefficient of discharge. There is a formula. Okay, it's 45 degree, and this way it will be 45 degree. So it's totally 90 degree. Okay, when you are using triangular notch. Okay, you have to be careful while using triangular notch, because rectangular notch, this is bigger. Okay, when you increase the flow rate, still it's fine. But here you have to increase gradually. Otherwise, it will overflow very quickly. Okay, for a rectangular notch, it's okay. When you increase, okay, still you can easily take 5 readings. But for triangular notch, you have to increase gradually. Okay, if you increase too much, it will overflow. Clear?